we are going to discuss some important properties of electric field lines. This electric field is produced by charges, correct? We have two type of charges, one is positive charge and a negative charges. We know some properties of basic charges. Like charges repel each other, unlike charges attract each other, right? And at the same time, positive charges are produced positive field, negative charges are produced negative field, correct? So, like if you keep the charge in the space, around the space some region is produced, in that region field is produced, that field is nothing but electric field, correct? If you keep a positive charge, our field lines are originate from the positive charge and move away, right? At the same time, the field intensity, if you see the field intensity at close to the charge, field intensity will be larger than the away, correct? We know that electrostatic force of attraction and repulsion from the Coulomb's law, F is directly proportional to 1 by r square, correct? If we move away from the charges, the force of attraction and repulsion will be decreases. This is because of the field is reduced, correct? If we have the positive charge, the field intensity can be measured, okay? Field intensity measured by the voltage. If you see the close to the charge, the field will be higher, and if you move away from the charge, the field will be reduced, correct? Field will be reduced. And for the positive charge, electric field is produced from the positive charge, that is represented by the field lines. The field lines are always move away from the charges, from the positive charge. At the same time, if you replace the negative charge, field lines are attracted towards the charge. Field lines terminate at negative charge and originate at positive charge. This we can easily understand by keeping two charges simultaneously. See, this is negative charge, field lines are terminate at negative charge, and if we keep the positive charge, see here, from the positive charge field lines are originate, and at negative charge field lines are terminate, okay? So, the region around the charge field is produced, that field is called electric field. This electric field is measured by electric field intensity, and this electric field is mentioned by geometrical or imaginary field lines, that lines are called electric field lines. Now, we are going to discuss some basic and important properties of these field lines respective of positive and negative charges. See here, electric lines of force due to point charge. First point, we know that if charge is greater than 0, means this is positive charge, correct? If charge is greater than 0, the field lines are originate from the charges, and the length of this field lines represents magnitude of the field, and arrow mark represents direction of the field. If you see closely, the field lines is larger when charges are near. If field lines is very shorter when it is away from the charges, correct? So, this if charges is less than 0 means negative charge, then field lines are towards the terminate at negative charge. So, this is the electric field lines due to point charge. So, representation of electric field in terms of field vectors. So, the size of arrow represents strength of the electric field. Next, so this we can easily understand. If we have the positive charge, field lines are originate. If we have the negative charge, at negative charge field lines are terminate. This is first point. This is electric field lines due to single point charge, whether it is positive or negative, the representation of field lines like this. And the representation of electric field in terms of electric field lines. And next point, the electric field lines of forces due to pair of equal and unequal charges. It's like a dipole. We will discuss what is a dipole. And if you have the positive charge and a negative charge, If they are separated by small distance, that is called dipole. If we have the dipole, the electric field lines originate from the positive and terminate at negatives. As like before we seen that simulation, right? Similar way here, if positive charge la irundhu electric field lines originate aagi negative charge la terminate agum. This is the electric field line representation if we have unlike charges. Unlike charges, we know, right? Unlike charges are attract each other because we know that electric lines of force contract lengthwise. See, here the positive, negative, in between electric field lines are contract lengthwise to represent attraction between the two charges. So this is the reason why the unlike charges are attract each other, okay, because the field lines are contract each other lengthwise. See, this word is very important for theory based question, for especially for NEET they will give the directly this line. So this attraction due to lengthwise contraction of electric field lines in between the unlike charges, okay. And the field vectors, this electric field is a vector quantity. The direction of this field vector we can get just by drawing the tangent at any point, okay. At any point we can get the direction of electric field lines. This is the representation of electric field lines of forces due to unlike charges. Next we will take pair of equal charges, electric lines of forces due to pair of equal charges or like charges. We are having positive charge and another one positive charge. We know that electric field lines are originate from the positive. So here we have both positive charges. So from the both positive charge we are getting electric field lines of forces. See the representation like this. Here in between the two charges, in laterally these field lines are laterally expand. See, electric lines of force exert lateral pressure in between the two charges. So this pressure is the reason because of the repulsion between the two electric charges and two like charges. Especially ரெண்டு like charges இருக்கு அப்படினா அந்த ரெண்டு like chargesக்கு இடையில இருக்கக்கூடிய repulsion force because of this lateral pressure, okay, length, this sideways lateral pressure. This is the reason the two like charges are repel each other. Here similar way we can keep for negative charges, we can study for negative charges also, okay. So this first case is electric lines of force due to pair of unequal charges, we are getting attractive force because of lateral contraction between the two charges, lengthwise lateral contraction between the two charges. Inga repulsion force because of the appearance of exert of lateral pressure to represent repulsion between the two like charges. This is the third property. And the fourth property, electric lines of forces due to uniform field, we can represent like this. See here, for uniform field electric lines of forces always originate from positive and negative, we know that. So appo electric field lines pathinga appadina the direction of electric field lines always from positive to negative. So remember, so electric field, uniform electric field in the sense, simply we can say the separation of positive charge and negative charge. So which exert the field and which has the one directional representation, that lines called electric field lines. If we maintain uniform positive charge and uniform negative charge in between some distance, then in between that distance we have the uniform electric field. So this is the representation of uniform electric field. This is fourth point. And fifth point, the electric lines of force are simply the imaginary lines. So these are imaginary lines only. So there is no any physical existence of these lines. This is for understanding of this electric field. We are imaginarily considering one line, that is the imaginary lines. Next, if a unit positive charge placed in electric field which tends to follow the path along the field line if it is free to do so. That means simple, if we keep the positive charge in the electric field, this positive charge tend to move along the direction of electric field. This is the sixth point. Okay. And the seventh point, the electric lines of force originate from positive charge and terminate at a negative charge. This already we discussed enough with the simulation and concepts. Okay. So electric field lines always originate from positive, originate from positive and terminate at negative. This is the seventh point. And eighth point, the tangent electric field line at any point gives the direction of electric field at a point. So the electric field lines can be represented with straight line as well curve. Okay. If it is straight line, the representation of direction is very simple, correct. But if it is curved, we have to represent direction that can be easily obtained by drawing a tangent on any point in the electric field. This is eighth point. See this, if it is the electric field lines is curved at point P, if you want what is the direction of electric field, we have to draw the tangent. So this tangent gives the exact direction of this electric field lines. This is eighth point. Next, the ninth point, the two electric lines of force can never cross each other, because we know that electric field are vector quantity, so it must have the one direction. If suppose the two lines are electric field cross each other, then at the point of intersection there will be two tangent, correct, there will be two tangent. It means there are two values of electric field at that point, which is not possible. So further, electric field being the vector quantity, there can be only one resultant field at a given point, so represented by one tangent at a given point. One tangent only gives the one directional representation of electric field. If it is intersection, at intersecting point we will get a 2. See like this. If you have the if there is a intersecting at this point, at intersecting point we will get a 2 directional electric field. One is E1 and E2. This is not possible. So at the resultant point there is no field, so it is not possible. This is the ninth point. Okay. Next, electric lines of force are closer. If we have the charge plus q or minus q, at closer it will show as a crowded when the electric field is stronger and the lines spread out when the electric field is weaker. See, if we have the two charges plus q and minus q, at plus capital Q, electric field lines are crowded, right, which is closer, and in the small q it is spread out. If we see the strength of electric field between these two, the capital Q is greater than small q, because the field lines are crowded here is spread out, right. So capital Q is greater than small q, and the electric lines of force are perpendicular to the surface of positively or negatively body. If we have the any kind of surface, it may be circle or it may be rectangle or it may be square, the electric field lines always perpendicular to the surface. This field lines is always perpendicular to the surface. That is the representation here. If suppose you have arbitrary structure, then here also at particular point the field vector is perpendicular, not compared to other point. At this point the field is perpendicular to this point. Okay. This is point 7. And we know already electric lines of force contract lengthwise to represent attraction between the unlike charges. Unlike charges, attraction between unlike charges due to the field lines contract lengthwise. This is 8th point. And 9th point, electric lines of force exert lateral pressure to represent repulsion between the two charges. This is 9th point. And 10th one, the number of lines per unit cross sectional area perpendicular to the field line is directly proportional to magnitude of intensity of electric field. Means one particular area, if the number of field lines is greater, means the field intensity is greater. Number of field line is smaller, means the field intensity will be smaller. Adha kuduthirukkom. dN by d is directly proportional to A. If dN by d is greater, then electric field strength is greater. If dN by dA is smaller, then field strength is smaller. And next point, the electric lines of force do not pass through the conductor. Hence, interior of the conductor is free from the influence of electric field. That means what? We know that the charges are reside on the surface of the earth, correct? For the conductors, surface of the conductors. So, and also the field lines will not pass through the conductor. If you have the uniform field and if you have the conductor, we know that there will be the internal separation of charges, and the field lines always start from positive to negative, correct? Upper field lines, electric field lines are not passed through the conductor. So, it will only resides on the surface. That is the reason in during thundering and lightning, people are saying to stay inside the car or inside the house. Do not stay under the tree, like, okay, because these all conductors are act as a electrostatic shielding. If you are staying inside the car, even if it is a heavy lightning and thundering, that will not affect us, okay, because all conductors are acting as a electrostatic shielding, as like a cavity, okay. This is 11th point. Next, electric lines of force can pass through the insulator. Electric lines of forces are passed through the insulator. So, these are the 12 important point you have to memorize. You have to memorize and you have to understand better way in the electric charges and field. Then only you can ask, you can solve the problems, you can answer the question if even they ask any kind of questions, okay. So, these 12 points are very important.